So for example number 5, we're going to use the integration formula at the top here. So if we integrate dx over x squared plus a squared, that's equal to 1 over a tangent inverse or arctangent x over a plus c. So again, let's apply the partial fractions rules here. So for the first one, let's take a look here. So if we look at the first step, we have x cubed plus 4x. And if we factor that any further, we have x times x squared plus 4. So we can't factor that any further. So then we have to rewrite this partial fractions in the following form. We have 2x squared minus x plus 4 over x cubed plus 4x, and that's going to equal the following. So we have a over x, which is the first factor, and then plus, we're going to have bx plus c over the second factor, which is x squared plus 4. Okay, now if we multiply all three terms by the LCD, which is x times x squared plus 4, then we get the following resulting partial fraction equation. So we have 2x squared minus x plus 4, and that will equal a times x squared plus 4 plus we would have bx plus c times x. So then let's factor in, or at least let's reorder our right side so that we have all our x squared terms. So the two x squared terms that we're going to have are a and b. So we have a plus b, which are our two coefficients of our x squared terms. And then we have one coefficient for x, which is cx. And then we would have one coefficient for a, which is 4a. And so therefore, we would then say that our first equation is a plus b, which is equal to 2. We know that c is going to equal -1. And we know that 4a is going to equal 4. So then ultimately what it's going to give us are the following values. We're going to get a is equal to 1. We know that b is going to equal 1. And then c is going to equal -1. Now we can go ahead and then apply our integration. So we know that our original question was 2x squared minus x plus 4 divided by x cubed plus 4x dx can now be written in the following way. So we would have 1, which represented a over x, plus x minus 1 over x squared plus 4 dx. Okay, so now what we want to do is then we can rewrite this in terms of three fractions by splitting up the integrals. So we're going to integrate the first term, which is 1 over x dx, plus the second term, when then we're going to split our two fractions with our two numerators. So we're going to get x over x squared plus 4 dx. And then minus, we're going to have 1 over x squared plus 4 dx. Okay, now the first one, we know that the substitution can be quite simpler here, which is just going to be 1 over u du. And over here, if we let u equal x squared plus 4, then we know that du is going to equal 2 dx, which ultimately tells us that dx is going to equal 1/2 du. So therefore here, we're going to factor out the 1/2, and this is going to be 1 over u du. and then minus, now we're going to use the formula from the beginning here. So the formula that we're going to use to integrate this is the following. So we know that this is going to be 1 over x squared plus 2 squared dx. Okay, so here now we're going to finish. So we have the natural log of the absolute value of u plus 1/2 times the natural log of u minus, well, we know that a is equal to 2, so it's going to be 1 over 2 times the tangent inverse of x over 2 plus a constant, and we're going to call that k here. And now let's go ahead and substitute the values of u. So we have the natural log. Well, u for this integral would have been x. So it's the absolute value of x plus 1/2 times the natural log of x squared plus 4 minus 1/2 tangent inverse x over 2 plus k.